Hello everyone, welcome to my channel. So in these lectures, we will continue our introduction of the probability. So here, today we will talk about the permutation of a sample space or the event. So this is also one method of accounting technologies. So it means use this permutation, we can find how many outcomes in a sample space or in an event. So first, let me write down what is the experiment we will have to use this permutation. So the experiment is about n objects. And here, for this one, we interested in how many ordered arrangement of these objects. So here, like this question said, if we want to find the ordered arrangement of these objects. So in other words, in general, this means this object have some difference, right? So it means if we talk about like ordered number 1 until 9, we can say 1, 2, 3, 4, 5, 6, 8, 9 is different with 2, 1, 3, 4, 5, 6, 7, 8, 9. So because all of the numbers are different, so that means if we change the order of any of them, so we have totally 9 objects, and if we change the order, it's a different arrangement. So here for this n objects, very important thing is when we talk this are ordered, that means in other words, these n objects are different with each other. So we can now say we order 3 red balls in a line. So no matter how we change these 3 balls, because they are all colored as red, then we don't have any order of these 3 balls. Okay, so then how we can get a number of this ordered arrangement? So here I can give you the formula of this. The answer is n factorial. So here, this one, if you learn, maybe you already know this symbol in the maybe algebra or some course. So here we have this one. So this meaning of this factorials is n times n minus 1 until n until 1. But for this factorial, there is a remark of this one. So we will know, like if n equal 1, then this is just we have 1. So 1's factorial is equal 1. However, for 0's factorial, this is a little complicated. So that means nothing multiply each other. But in the mathematics, we just cite this will equal 1. So the 0 factorial is equal 1. Okay, so this is permutation. And also we have a topic of the permutation of subsets. So what is a permutation of subsets? So of course here when we say subsets, it means we want to find something of the total set. So the total set, we have n objects and we select a subset of them. So for example, we select r objects from them, or we select r elements from the total n elements. So if we write this is we want to know the number of permutations of a subset of r object, select from a set of n different objects. So here, this one, we also have two number. One is r objects, one is n different objects. So what's the importance of this different? Because if we have a different objects, right, as we talk in the previous terminology, permutation, so it means if we change the order, then this will have different selection. So that means here, for this question, this is also about ordered arrangement. So in this one, what is the answer of this? So the answer of this, actually we have a notation for this. So we denote this by P upper N and sub R. So this means we select R objects from N, and this is we get the permutation of this one. So the answer of this one is N times N minus 1 times, it's not until the number 1, but here we until the N minus R plus 1. So in fact, if you're familiar with factorials, this is N factorials divided by N minus R factorials. Okay, so this is the answer of this permutation of a subset. Maybe you're interested in why we have this equation. So let me explain this to you. So about this one, what's of this when we select items, R items from N different objects, when we select the first one, which in other words, when we have an order of R position, and we want to select for the first position. So how many choice do we have when we select the first one? So now because in total we have N objects and we didn't select any of them. So that means for this first position, we will have in total N choice. Right, so this is what we have for the first position. However, when we go to the second position, then now how many choice do we have? So because we already select one from the N objects, so now what we left, we only have N minus 1 choices for this one. And this will continue until the R position. So now in the R position, what we have, we already choose R minus 1 objects. So that means now we have N minus R minus 1 choice left. So here we can also rewrite this as N minus R plus 1 choice. Okay, so this is what we have. And now we have the finished whole of the select, and in this one it means we have R objects, and for each of them we have several choice. So this will very similar to our previous lecture. So previous lecture we talk about the multiplication rule of the sample space. So now this is actually we use the multiplication rules here. We have different position for each of them. We have N1, N sub 1 choice, N sub 2 choice, or way to finish the step. So then the answer of this one will be times them together. So that's why it's N times N minus 1 times until times the last one is N minus R plus 1. Okay, so this is why we can have this equation for the permutation of subsets. So now let me give you one example of this permutation of subsets. So here let's look at the license plates, which we use this example in our previous lecture, multiplication rules. So now this license plate is contains 4 letters followed by 3 digits. So for 4 letters, we only use small letters. So this is, maybe we only use the capital letters. So we'll have 26 choice for each of the letters. And then for the 3 digits, we can choose from 0, 1, 2 until 9. So we have 10 choice. However, it's a little different is here we don't allow the repetition of the each of the position. So now the question is how many license plates can we have? So in this question, in fact, this is about a question of permutation of a subsize. So what this one? So here in the question, we can divide this to two parts. The first part is we talk about the first four position. So in other words, this is about the letters. So now what we want to do is we want to choose 4 letters from the total 26 letters. So that means here what we want to do is, it means if we talk about PRN, now our R is equal 4 and our N is equal 26, right? So this is 26 different objects and we want to choose 4 of them. And also we need to order the choice. So that means if we have a plate start with A, B, C, D, this is different with a plate with B, A, C, D, right? So that means the order is important here. And now what we will have is we just use our formula for this question. So it means this is 26 factorial divided by 26 minus 4 factorial. So in other words, this is 26 factorial divided by 22 factorial. And if you want to compute this, you can use a calculator to get the answer as 358,800. So this is the answer for the first part. And then we will have our second part. The second part is the last 3 digit. So now the idea of this one is very similar. So now what we want to do is we want to choose 3 numbers from the total 10 digit. So this one is actually we just change the value of R and N, but the idea is exactly same. So it's still about to choose some subset from different objects, and we want to find how many ordered arrangement we will have. So the answer of this one now is choose 3 objects from total of 10. And this is 10 factorial divided by 10 minus 3 factorial. And again, you can use your calculator to help you find the answer. The answer is 720. And now, do we finish this question? The answer is no, because we divided this question to 2 parts, right? Part 1 and part 2. In other words, we divided this question to 2 steps. So now the final one is we need to combine them. So this will use the multiplication rule of probability. So you can look my previous lecture about this part. So now we combine these 2 steps. So if we combine these 2 steps, what we need to do is we need to times these 2 numbers together, because this is a multiplication rule. So we need to times this huge number together. And of course, you can use your calculator to help you find the answer. And the answer will be like this. So this is our answer for this question. So if you compare this question with our previous example in the multiplication rule, you should find the answer of this one. If we don't allow the repeat of the letters or digit, then we will have a much less lesson place we can choose. Okay, so this is about permutation of a subsize. Before the end of this part, let me give you one more formulas about the permutation. So now this question is a permutation of similar objects. So what this means? This means now in total we still have a number n objects, but instead of n different objects, so now here these n objects have some of them are similar to each other. So we can group them by R different group. So now for the first type, we have N1 in the first type. And then for the second type, we denote this by N2 objects of this second type until the N sub R objects is all look similar, and we call this as NR types. So now for this one, if we think about this, you can, for example, we think about this as if we have maybe number A, B, C, right? So here, if we order this, we will know the first two AA actually they are same type. So this means if we change the order of these similar objects, then we still get AABC. It didn't give us a one more permutation. So that's why in this question, the permutation of similar objects, we need to remove the ordered, or say the change or switch between the similar objects from our total number of permutation. Now, so if we think about this, what should we do? So in fact here, different with the multiplication, if we want to remove something, it means we will divide it something. So that's why the formula for the permutation of similar objects is look like n factorial divided by the product of n1 factorial, n2 factorial until n sub r factorial. So this is the formula for the permutation of similar objects. So here, let me give you one example of this. So this question is about experiment we talked about in our previous lectures. This is we send 3 signals in concessions, and then we record whether this signal are arrive or not. And then here we interested in one event. This event is we will get exactly 2 signal of this 3 signal. So then for this one, so the question is how many outcomes we will have on this event. So now this question, what we do is, in fact, this question is about permutation of the similar objects. So here, because what we interest is, we only interest about exactly 2 signals are arrived. We don't care these 2 are first or second or third, and first we don't care about which 2 we get. We only care about we get exactly 2. So that means arrive this, we will have 2 items about arrive, and we will have 1 items or outcomes, objects as not arrive. So here this means we will have 2 types. The first type, we can say this first type is A. So in this one, how many objects we have for this? So here this is 2, because we want to 2 signals arrive. And then we also have another type. This is N. So in this type, how many objects we will have? So here for this one, we have 1, because we want 1 signals are not arrive. So that means if we say this is our first type and N is our second type. So now in this one, we will have our n1 is equal 2 and n2 is equal 1. So by the previous equation, we will have n equal n1 plus n2, right? So that means here we will have, in total, we choose interesting about 3 objects. So now, with the answer of this question, the answer will be use our formula, right? So the formula is n factorial divided by the product of the n1 factorial and n2 factorial. So if we plug in the value here, it's a 3 factorial divided the product of 2 factorial and 1 factorial. So if you use your calculator to compute this, the answer of this one is 3. Okay, so this is one example of how we can use permutation of similar objects to solve this question. And as I said, this is also one method of counting technology. We can use this way to find how many outcomes we will have in one sample space or events without write down what is exactly outcomes in this sample space or event. So in our next lecture, I will continue on the counting technology of the outcomes in the sample space and events. So see you in the next lecture, and please subscribe this channel.